So we're still on our 4, 6 notes. And I want you guys to try this part out now. Remember, you only move the negative exponents. The positive exponents get to stay. So does that 12 have a negative exponent? No. Does the t have a negative exponent? No. Does the r have a negative exponent? Yes. So we're going to take that r, move it to our denominator, and when we move it to our denominator, it becomes r to the 8th power. And then what remains in the numerator? The 12 t to the 5th power. Yep, 12 t to the 5th power. Nice job. That's awesome. And then today we're also going to be learning about the rule for what to do with zero exponents. So go ahead and decode that for me, please. So decode zero exponent. Zero exponent. All right, now, something very interesting happens when we have an exponent of 0. Let's say I have 3 to the 3rd power. What's 3 times 3? Times 3 more. 27, right? We would get 27. Now let's say I have 3 squared. What's 3 times 3? 9. Good. Now notice my power is decreasing by 1, so 3 to the 1st power would just be what? 3. So what do you guys notice is happening in this right-hand column here? We're dividing by 3, right? We're dividing by 3 each time. Each time that my exponent, or each time my power decreases, I'm just dividing by 3. I'm taking away one more multiplication of 3. So if I were to divide by 3 again, what's 3 divided by 3? 1. And then over here, I had 3 to the 3rd, 3 to the 2nd, 3 to the 1st, 3 to the 0th power. We're going to go to 0 first. Anything to the power of 0 will always be 1. If we flip back to this page right here, see how we did that same pattern? We kept dividing by 2, dividing by 2. Let's look at this middle section here. When we had 2 to the power of 0, what did we get? 1. And then if we look at this section here, when we had 3 to the power of 0, we get 1. So guess what 5 to the power of 0 is? 1. Guess what 72 to the power of 0 is? 1. Guess what 16 to the power of 0 is? Guess what x to the power of 0 is? 1. Guess what y to the power of 0 is? 1. Guess what 92 to the power of 0 is? Are you guys getting the pattern? Anytime you have 0, it's 1. Very good. Anytime your exponent is 0, it's always 1. So if we have a to the 0 power, what does that equal? 1. And it's just that simple. Anything to the power of 0 is always 1. So let's take a look at this example here. I find it helpful in example 2. Between the 3 and the x, what is there? We don't see it, but we know it's there. Go ahead. Multiplication, right? That technically says 3 times x to the 0 power. So I want you to go ahead and rewrite this as 3 times x to the 0 power. I like to write that multiplication in there. And we have to simplify. Well, the 3 we can't do anything with. But what's x to the 0 power? 1. So I'm going to go ahead and write a 1 there. Bring down my 3 times. And what's 3 times 1? 3. So that question actually simplifies to 1. Or 3, I'm sorry. 3. Now this next example, I see t to the 0 power. What's t to the 0 power? 1. So I'm going to write 1 times 5x. What's 1 times 5? So I have 5x. And that's my answer. Anything to the 0 power is just 1. Yep, very good. Now let's look at this one. What is y to the 0 power? 1. So I'm going to write 1 times x to the negative 6th power. Now, for our final answer, a lot of people are tempted to just write x to the negative 6th power and call it good. Yeah, very good. Not a good idea. All right. I don't like negatives as my final answer. Now, sometimes IXL will allow you to get away with it, but on the testing quiz, I don't want you to. So I'm going to take that x to the negative 6th power, and I'm going to move it to my denominator. So the 1 stays in the numerator, and the reason the 1 stays in the numerator is because the negative 6 only applies to the x. So I'm going to move that x to the 6th power to my denominator. The 1 remains in my numerator, and that is a much better, more appropriate final answer. Yep, the negative in the numerator goes to the bottom. Okay, well, I want you to write this one too, okay? So write this one down. All right, we're going to do example 3, and then we'll be done with notes for today. Example 3 tells us to find the product for quotient. Your final answer should only have positive exponents. So the directions literally tell us we can only have positive exponents. So I've got x to the negative 7th power being multiplied by x to the 3rd power. We learned quite a few days ago. When we're multiplying powers, they have the same base. So what's my base for this example here? My base is x, right? If I'm multiplying powers with the same base, what do I do with their exponents? We add them together. What's negative 7 plus 3? Good, negative 4. So negative 7 plus 3 is negative 4. Is that an appropriate final answer? So move that to the denominator. And what remains in the numerator? 1. Yep, just 1. Very good. Now that's one way to do it. Did somebody do it a different way and get the same answer? Okay, you know what some people recognize at the beginning? See how there's an x to the negative 7th power? There are some people that as soon as they see that, they put that x to the 7th in the denominator. They keep the x to the 3rd in the numerator because that was positive. Is that what you did? That's awesome. I love it. Now, do we have more x's in the numerator or denominator? How many more? 4. So it would become x to the 4th. And then these x's are all gone because they canceled. So we get 1 over x. That would work as well. All right, go ahead. Yep. Yep. And then you have to know that it needs to go in the denominator because we had more negatives. So then you have to move it down. Go ahead and do that last one on your own. All right, who wants to raise your hand and give me your first step? What was the first thing that you did for this one? And again, there are 2 different ways to solve this, so don't be shy. Start by adding your exponents. What'd you get for negative 4 plus negative 5? Negative 9. So did you guys start off by getting y to the negative 9th power? Okay. Now who can help me finish it from there? That's an okay answer, but there's a better one. Go ahead. Very good. Very good. We're going to move that y to the negative 9th power to our denominator, make it a positive, and then there's a 1 remaining in our numerator. So we get 1 over y to the 9th power. Very good. Nice job. How many of you actually had that right, but you were too shy to share? Good. Awesome. All right. I highly, highly, highly want to encourage you guys. Please make sure you read the directions if you're allowed to have positive or negative exponents. IXL does occasionally allow you to have those negatives. Yes, go ahead. Yep, I'm going to give it to you right now. The 4-6 worksheet. Now you'll notice we're going to go in this middle section here. See where it says write the expression using only positive exponents? You just have to rewrite this to make that exponent positive. So I want you to do 2, 3, 4, 6, and 7. So 2, 3, 4, 6, and 7. Yeah, heck, let's do number 5 too. 6, 1, or 2 through 7. And then I want you to do 14, 15, 16, 17, 18, 19. And upload a picture to Google Classroom when you're done.